Hey, there we go. Come in, everybody. We're already 10 minutes late. This will go off your cocktail time. So, welcome to the next session. Okay, if somebody could please close the doors so we don't have too much noise in here, that would be great. So, I'm here to introduce... Who am I? Well, I'm Sander, but I'm not important. I'm just introducing other people. So, besides, I was just on stage. I hope you still remember me. I'll be introducing the speakers for this session. The first one is about cybersecurity, and apparently we're on a need-to-know basis because all they told me that his name is Andrew.
Now I'm really anonymous. Hi everybody, Andrew Dolgano. I work now in Nokia, dealing with data center related stuff, but worked for like 25 years in this business. 4 of those years with national security company, building network security stuff. That wasn't a Nokia. And as a result, I'm also talking about security when it comes to our Nokia gear and generally what happens to industry. So if I can get my slides on, I'm assuming they will show up here. Just a quick acknowledgement here to Craig Lobowitz, who heads our deep field business and technology, and a lot of stuff in that presentation is thanks to Craig. Well, I have Okay, so a quick one. Cybersecurity is a interesting topic. We all know the attacks come from the network predominantly. The network is this beautiful highway to attack us left and right. Attack us as individuals, attack businesses, attack infrastructure. But how we handle it, how we're making this big red disappear, really depends where you are. And there is really 4 types of organizations. You have your intelligence, highest level of government. Those are the really only guys who really do security. Everybody after, and that may be a shock because defense is in the next one, everybody after that really is about connectivity, and then how much security they do depends on really how much they care about the perception of security when the impact of an attack happens. Not that green doesn't show up. So, and it goes, from a really secure, then defense, government, critical infrastructure. Okay, we don't want this stuff to really be penetrated, to enterprise, who really, they care about shareholders more than they care about security. And then you and I, who pretend that we care about security, but really don't do much as individuals. So why we're gonna be talking about DDoS and how this evolves and what's happening and how bad this makes things? Because the DDoS is a massive traffic volume type of an attack, and a lot of the existing security things cannot keep up with the capacity of the pipes we're delivering. So you have to be able to remove as much as possible, as cheaply as possible. Otherwise, the very specialized things that are expensive cannot do their job. And the problems with DDoS are, and its growth and evolution, are multitude. First, IoT. If you look at your basic IoT device, very cheap, firmware never upgraded, so whatever you got is there. It's a beautiful mechanism to launch DDoS attacks. Anybody in this room, if you do not know how to do it, 15 minutes on internet and you can launch DDoS attacks. That's how easy it is. And now, thanks to our service providers, we really have nice pipes to launch a lot of those DDoS attacks. Because, before we had the ADSL, so whatever internet we all had, not much upstream. The more upstream you get, the more single fridge, single switch, smart this, smart that. Everything that's smart, you should think DDoS attacker, a phenomenal source of bot, yeah? And things get bad because the whole remote DDoS really became a weaponized. And we see it, and okay, here's just a few headlines, doesn't matter really which one you pick. The state-sponsored, and by state-sponsored it doesn't necessarily mean national, it also may mean organized crime, is attacking us constantly. There's thousands of attacks daily. Most of them we don't notice because they're not there really to attack us. They really kind of test. If we want to, can we attack you? So every now and then something happens and we're seeing results of attacks, but even those are just tests. Those are not really attacks. So coming from a space, again, from the national security, I can tell you pretty reliably, those are just tests. So, but what's gonna happen when they're gonna become real attacks? Again, we need to kind of figure out how we're gonna be protecting internet and infrastructure from those. And the botnets are pretty much becoming the dominant part of how we generate. Taking aside that with number of devices, you can buy a lot of those very cheaply. You can go, you can attack. If you don't like me, you can buy, if you know my IP addresses on some devices, you can do an attack against me for dollars. For dollars now. A lot of people sell them. So if you have this kind of experience, what does it mean? And here's an example, and I picked up one that's hopefully not too controversial, but this is an attack against US government. So you would think, hey, those guys protect themselves, yeah? 830 gigs attacked by 31,000 IoT devices from European Union, from Asia predominantly. So it doesn't matter where you are. It doesn't matter where you physically as an attacker, you pick up devices. What did they pick up in this instance? A camera. Very easy. You do a crawling on internet, you can pick up anybody who is most of us are techs here. If you know how to crawl internet, it's doable, not that complicated really. And you can discover those devices. Once you discover the device, you can figure out what models they are, what firmware they run. In this particular example, some whatever camera from 2016, if you go look for the model, you can find CVEs. If you find CVE that's newer than the device, you can go to GitHub. You can find the code to explore that. You have now all the pieces to run, to put a bot in place. So now you just need to find those devices and voila, here is your attack. So that's one problem of DDoS. The second problem of DDoS is QUIC. So QUIC, a very good protocol. I guess Google guys at some point became really upset with all the networking stuff, how it didn't work with applications. So the nice solution to that was, hey, let's move everything to the application. Let's move the TCP control, let's move the TLS, let's move parts of HTTP. Everything moves into the QUIC. Now we in an application space, we can really design applications around any issues in the networks, which is true. But the problem is we made everything in the network look like UDP. And there was a claim, okay, this will be more secure. But there is a difference between security and privacy. Yeah, so what they really have done is made most communication more private. But by doing it more private, not necessarily more secure. It's like your WhatsApp. It's not secure, it's private. It's a big difference. For example, iMessage, not secure, private. That's very, very big difference between what's secure and what's private. So in Quick, hey, we have built-in encryption from TLS. Great. It can be done on 1.3 and not 1.2.1.1, which anybody with a laptop and 15 minutes on internet can pretty much break. It prevents you from tracking. So as you move, you cannot be linked to the interface. So a lot of capabilities that show on your devices are related to Quick usage. And it's platform OS agnostic, so again, allows much faster development on an application layer and delivery of high capacity, high bandwidth. But like with anything encrypted, as soon as you encrypt everything, it's very easy to sneak stuff under because now it's encrypted. So most of the tools that we use cannot really deal with encryption for proper identification. So you're making a fantastic medium to now deliver malwares and everything else. Because it's an UDP, it can be very easily launched from anything. So you have a larger and larger army of bots and botnets, yeah? And to anything on the network, hey, UDP 443. If you block that, you're blocking internet. So very difficult to kind of work around now. And if you look at the Quick, so let's look at the Quick, yeah? So this is a server to client response. You look at what's happening on the wire. If you want to kind of use the packets to identify and block DDoS, what can you do with that? Well, you cannot do connection tracking because all you see is UDP 443. Because you're seeing TLS, you can do profiling because you're seeing things related to server name, this blue square from TLS. You can do URL filtering based on that information. If you, in the middle, on the wire, you can do payload-based blocking because you can do inspection as long as it's not encrypted, which it may not be. The problem with that is it's just too much capacity to do on a reasonable, in a reasonable manner a fully based payload inspection at line rate all the time. Most of the things can change their characteristics. So it's very, if you know how the payload inspection works, a lot of those tools can be worked around with relative ease. So, you can do packet filters, but you need more information. Now, if we look a little bit further, with more and more features added to Quick to give us privacy, well, one of them, with encrypted hellos, will remove everything from, so no more TLS profiling, no more URL filtering, no more payload inspection, really. So now you have really a trouble. And that's why we believe kind of that the packet filtering based on source identification and reputation is pretty much going to be the only truly universal mechanism forward. So it's easy to say how we're going to do this, yeah? So first you need to figure out how the DDoS event takes place. It applies to Quick, but it applies in general, yeah? So the easy indicator is always, massive spike in the traffic. But massive spikes do happen for a valid reason. So on its own, it's not a sufficient condition to look at we have a DDoS. So the next piece is anomaly of traffic. So if you do proper telemetry from your routers, from your network, You continuously, you have a big data engine, analyze what's normal, what's anomaly, based on the time of day, based on the sources, destination. You can do this as an additional piece of information. Again, on its own may still not be enough. That's why the key really now comes to understanding who is talking to whom. So knowing the sources of the traffic, because as soon as in your anomaly you see one of those sources that you know are vulnerable, that they can generate DDoS, you suddenly can extend that information to any new bot sources in the network. So how we do that? Well, continuous source identification. So knowing the bad actors. There is no easy way to do that, but continuous fingerprinting of the entire internet. If you look at it, every IP address you can crawl. In some countries you have to be inside. In some countries you need to know how to go again, across the walls that they built. But it's all about finding the botnets, it's all about finding the booters, it's all about finding IoT devices and then learning what those IoT devices are, and then learning about, hey, if this is your camera, this is the firmware, those are the vulnerabilities. This is the likelihood of that device becoming a source of a botnet in the future. Yeah? And then kind of looking at the traffic that they may be generating, if you can see some of that traffic on kind of on an average basis. And then a lot of, I didn't want to put AI because it's like everybody's using AI. I'm tired with like pretty soon this will be an AI water. So I didn't use AI, but like it's a lot of machine learning, really training your systems on the information you learn so they can quickly make a decision. The second thing to kind of identifying that is knowing the attacks. So we collect, every vendor does it from security space, but we collect all the information on all the known attacks that we face or our customers face and share with us. So that database, allows us to characterize attacks, characterize the packet sizes. So if a given attack gets repeated somewhere else with similar pattern characteristics, again, we can use it to identification. And then you put this all in the mitigation compile engine, which is trained on both the, here's the IP address, what this IP address is, how likely it is to be source of the DDoS attack. Here is the known DDoS attacks, lots of, magic really happening inside. But fundamentally, if we were to block something like that, what packet ACLs would we use? And then when we see something like that, we can then create a ACL-based protection mechanisms to mitigate the attacks. Yeah? And what kind of match criteria we use depends really on the equipment we talk to. So that's kind of how it looks. Simple. It's relatively simple on the devices, much more complex to kind of make this happen. But hey, here's the rule. We know the protocol usually is easy. There is a prefix of attackers that, once you see the traffic from the routers, and I'll talk about second how we do that before, we can say, hey, this is the port, this is the protocol, this is the attackers, this is something about the packet, let's say in this simple example, something about the packet length or something about the TTL range, maybe they're too distant, often a good indication to find the rules. So now, because the botnet attacks become really massive but quick, a lot of botnet attacks last, minute two. They dare to overpower the host. They dare to kind of to overpower the server. They dare to inflict a little bit damage, but do not last too long. Why? Not lasting too long is a little bit of a way of protecting from systems from really defending quickly enough. And if you have those attacks and you have, let's say, botnets, I'm going to send botnet from this 10,000s of devices. And then I'm going to repeat 2 minutes later an attack from this 10,000 devices, or things like that. Or I'm going to randomize the things to make it much more difficult to detect. Yeah. So how are you going to do this? When you do this in the matter like that, it's important how you can detect it and how quickly you can detect stuff. So normally we used to, on our routers, we used to really depend on the net flow type of mechanisms, flow specs. The problem with those mechanisms is it takes now quite a bit of time to actually deliver the information about the traffic to the mitigation device or to the mitigation engine that then can analyze, is there an attack in place, and what should we do? So if you look at the top path here, if you on average our customers use NetFlow with 30-60 second type of timers. If you're using that means your first packet of attack can be up to 60 seconds before the system sees it. Then you need to feed it to the engine that can, post-process that information, find out whether the things happen. Well, luckily that's actually heavy optimized, very efficient. So that time of detecting, hey, there is an attack, and we need to put stuff in, it's very quick. But and then you add, hey, now we have to create ACLs, we have to instantiate them on the devices. So that's a net flow spec usually, or netconf. You have to program, do the data path, hey, add 10-15 seconds on average for a device. We're talking over a minute, really, over 45 seconds, but really over a minute in some cases. So that's not ideal when your attacks last 60, 70 seconds, 80, 90 seconds. Yeah, you're pretty much losing the majority of an attack, and then you have to go and go attack again and go attack again. So that's not necessarily the most efficient. So what we have started to do recently is do really sample port mirroring. Works generally very similar to NetFlow. It's just no cache. And from our systems, we send stuff we need in our mitigation engines to do from our routers to do the detection. So now we cut this time of finding the first packet of attack from 30-60 seconds to 1 second. So nothing else changes, but because we reduce 30-60 second delay to a 1 second delay, we shorten the whole time needed to install protection dramatically. So now you can much faster respond to any attack, protecting the servers much, much faster. And now, so that's how and that's this last slide, this is how we kind of put this really all together. Any router, additional information, we can also, depending on the networks we work with, that we can collect. Simple telemetry. The better telemetry, the better. The better telemetry implementation in the routing devices you have, the better, obviously, for the whole solution. Then, number two, this have like pointer. Number two, there are kind of, if you look, this is the, knowing the internet and knowing the bad actors. So I didn't talk about knowing the internet aspects, but pretty much crawling the internet and understanding where is your Facebook, where is your Instagram, where is your Google this, where is your Apple this, and regardless of where they sit, in what data center, on what part of the world. So feeding that information into our on-prem deployment of the mitigation system, and then as soon as we see the packets based on the information put together, you see real-time both the analytics on what's happening during the attack and the ACLs that are being instantiated and deployed in the network. We deploy this on our gear. Not too many, let me just say, not too many routers can line rate protect DDoS at the proper scale without impact on performance and impact on ACL. So, whatever you have in the network will depend whether you can use your routers that you have or you need something else, like a scrubbing device that we also deliver, or existing other scrubbing devices or things like that. It is though important, so that's pretty much last slide, but it is important because as I say, there is a lot of, in networking security, there is a lot of, I would say, old thinking. And really when we think of an old security, we really have to, if you remember this first slide, we really have to understand where we are and what money we have, and be very careful how we're spending this money. Because there's too often that I see people buying a certain type of equipment that is very good equipment, but not for a scale that you need. So a lot of capabilities are diminishing when you impacted by the scale of the traffic device needs to handle. So the security is really, whatever what you secure on your peering, it's really about the layering things. Removing things as cheaply as possible, because the attacks are becoming extremely cheap. So, and as your peering bandwidth, as your connectivity increases rapidly, it's not that easy to do application layer device at the 100 of gigs type of capacity. So you have to be kind of very cautious to what you put in where, and how you design your security of the network to make sure that you really get money for your dollars spent, and you understand what you're protecting and what you still need to protect. Thank you. So I know if there are any questions, I'm happy to answer. But since people want drinks, I'm not going to be offended.
Hi, it's clearly the stupidest guy in the room because I'm the only one that doesn't understand presentations and have questions. Nishal, no hats. A lot of our detection and mitigation systems today are still bound by source or destination, right? How useful is this in a future internet? I mean, we're seeing, much to my disgust, we're seeing like CGN roll out, like it's going out of fashion. And while, of course, you can control the extent of how and what you detect within your network, if I'm looking at something that's one network downstream from me, I used to run a transit network in this country many years ago. If I'm looking downstream at one of my customers who's implementing some kind of CGN, I mean, what are we doing today to detect or what are we going to be doing in the future to detect and deal with attacks that are coming behind CGN type networks?
Yeah, so mitigating, so I say, like, we do believe that you can mitigate with source. it's just understanding what this source really is and what it does. So talking CDNs. So as I said, we do a crawling of it on internet to identify bad guys, but also to identify good guys. When we will know a difference between sending a good guy sending a traffic and suddenly good guy, something that looks like a good guy, sending a traffic that they should never send. Yeah? So that allows us to also detect somebody spoofing the source, which used to be a really dominant way of generating attacks, and suddenly you would see very legitimate source from very legitimate customer sending something that makes no sense. So mitigating, yes, but it's back to really the same goes for your devices. Yeah, there's a lot of apps right now on dealing with where you're connecting, how reliable, how secure, what's the on a scale from 0 to 10, should you connect to that address or should you not connect to that address? It's kind of similar concept. The thing is, the magic really behind this is being able to continuously crawl the entire internet. And it is a massive task to undertake because it's not one location, you need multiple locations, you need to know how to do it, you need to understand how protocol works so you can get the information. You need to have a legal team that every now and then when somebody sends you a letter, why you're doing this and this and this, because we do it openly, we can respond, that's totally legal. There's nothing preventing us from sending this request. So it's all legit, but you need to know how to do this to be legit and to learn the information you need so you can catch based on the information that you have, yeah.
Hendrik Versage from Link Solutions. So the first question that immediately came up to mind is, how is the single website operator going to protect his site from these sort of attacks coming from the internet? Are you looking at something for them, or is it, and in the same sentence, a home user? Are you going to protect them, or is this a sort of solution that will only really be sensible for the bigger persons, the enterprises, those that actually sits in the middle between those website users and the clients?
Yeah, so that's a good question. So there is a majority. Okay, if I go back, can we get the slides back? The last one. Okay, sorry. So I just answered quickly. So the whole system is a software-based solution. Yeah? So you have an on-prem deployment. Now, that can handle whatever needs you have at whatever, and obviously based on that, I don't want to go into commercial, it's a technical discussion. So that's tailored towards any deployment. Then the mitigation, it really depends on what you have in your network. So there's multiple ways that we can mitigate. Our routers, a third-party vendor routers, potentially, maybe you have some scrubbers, maybe we can give you a scrubber for whatever you need, or maybe we can, we also run it in a cloud as a mitigation, but okay, now you need a capacity. So there is no simple answer, but there is multiple capabilities. Hey, there is a lot of colors here that we could work with us and put a deep field as a service solution in South Africa. For clients in here as well. Yeah, so it all depends really how you go, but there is options to tailor this. So again,
Andrew,
I'm
sorry I have to cut you short, but we're running out of time.
I'm happy to talk outside of the things for any questions. Thank you, guys.
So, thank you, Andrew. So, going from DDoS protection to more general internet resiliency in South Africa, the next speaker is Amrish. He's a researcher for ISOC, longtime Afrinic staff member, and he will go a bit more into the details of general internet resiliency and the resiliency index.
Thank you, Sander. Hi, everyone. Super glad to be back in Cape Town and back in this area. I remember my first iWeek actually was in Stellenbosch, not so far away, 2015. Yeah. So, yeah, my name is Amrish. I work for the Internet Society. I do mostly research over there, and I will tell you about one of the new products that we have launched a couple of months ago, which is called the Internet Resilience Index. And what I'm going to talk about today is the internet resilience in Southern Africa, with a focus on South Africa, of course. Okay, so what are we going to cover today? Obviously, this tool, as you know, at the Internet Society, we like to work with people that can potentially change things in in their own countries. So, talking to regulators, policymakers. So this tool really is something meant for regulators and policymakers. I'm sure there are not many people in the policy sphere here today. It's mostly network operators, but I'm sure you can get at least one take-home point from this presentation. So we will look at the past, some of the incidents that happen on the internet, some of the outages, and what could have been, or what are the impact of these outages, and what is the connection to internet resilience? What are the strengths and weaknesses of the Southern African region in terms of resilience, and what you as the internet community should do to make internet more resilient in your own community and own country. So the Internet Society is running a project called Pulse. Pulse is a data dashboard. So we collect data from different sources and we present data on different things such as internet shutdowns or countries shutting down the internet in their countries. And so we document how they are doing the shutdowns and the duration, and we also provide some cost calculation about what could be the business impact of those shutdown. We also provide some information about the adoption of key technologies such as IPv6, DNSSEC, TLS, HTTPS, so on and so forth. Another aspect that we look at is also concentration. How some market concentrated in terms of CDN providers, certificate providers, data center providers, and what we are going to talk about today is resilience. So we have on the website a tool called the Internet Resilience Index, which I've been working on for the past couple of months. So internet resilience, it's quite a complex concept, right? So let's try to bring that back to the notion of human resilience, right? So what would you say constitute the resilience of a person? We can think of their mental health, their physical health. Some would say their financial health. My wife would say emotional health. So there are different things, right? But the internet is, I would say, is the same. The internet is a complex ecosystem made of so many different parts. So we have to come with some sort of, we have to break it down into measurable pieces. And the way we did it is, as you see here, first, we need infrastructure for the internet to work. So we look at whether there is an existence of infrastructure, first of all, and how reliable this infrastructure is. Next is performance. You need at least some level of performance to be able to run any kind of service on the internet. If your bandwidth is crappy, you won't be able to watch your favorite YouTube video. Security, of course. Your network, your system, the ecosystem of your country should be secured enough for it to be able to resist to attacks from the outside, and we have a nice talk on DDoS. I will tell you how we use DDoS information not as a way to protect your network, but because you can also, as a network, you can also be potentially an attacker to others. So you need to know that you are actually you need to secure your network in such a way that you are not going to be an attacker to others. And finally, market readiness. We thought that, okay, the internet is not only made of technical things, we need to add what we usually call layer 8 and layer 9 considerations in that index. And we looked at market readiness, things such as market concentration. Do we see good competition in the market? Do we see good pricing in terms of internet services? So these are all captured in that last pillar called market readiness. But first, let's learn a little bit about some recent incidents. The AS4804 outage, Optus in Australia, that outage lasted 10 hours. It affected both fixed broadband and mobile communication, over 10 million individuals. As in many places, the same company is going to provide fixed and mobile and using the same backbone. And once there is something which is not running okay in the main network, in the core network, both fixed and mobile would go away. And this is what happened in Australia. Obviously, there is something to fix at the network level itself. I think the issue was some misconfiguration with BGP. So there is some amount of resilience or redundancy that needs to happen at the network level, but that's not my point here. My point is that if we look at the Internet Resilience Index of Australia, so I will only look at two things. It's a little bit blurry, so you might not see it. In the red rectangle down there, we are looking at market diversity. So the index is basically telling us that in Australia, market diversity isn't that great, right? So in the case of an outage, if one or two operators they go down, it means that maybe potentially half of the population, if not more, will not be able to have access to the internet. And this is what also happened in Canada. Canada had an outage that lasted 19 hours, also affected millions of subscribers. And you can see the costs, more than $140 million in terms of loss. And the very same profile, market diversity in Canada is not that great because the market is dominated by one or two players. Finally, this is a blog post that was written by Max, who did a presentation earlier today about the outage in Italy, where Telecom Italia has only one upstream provider, which is Sparkle, and the link between Telecom Italia and Sparkle was broken, and obviously, because they do not have any alternative link, and also because of lack of peering, their customer base suffered a lot from this outage. So this is how it looks like on Hurricane Electric. So on the left, you would see this is Telecom Italia. As you can see, only one provider. And I bet this case is very similar in a lot of countries across the world. If we look at their competitor, which is Vodafone Italia, you can see that they have many providers, at least 3 providers, So it shows a higher level of redundancy here. So now let's bring the conversation back to Southern Africa, and specifically also South Africa. So using the Internet Resilience Index, we rank regions. Unfortunately, Africa is lagging behind with 35% of internet resilience. And if we go into Africa, we also have sub-regions, and Southern Africa is doing the best. And within Southern Africa, South Africa is doing the best in front of Botswana, Namibia, Lesotho, and Eswatini. In general, South Africa is ranked 52 in the world. So this is a spider chart of the internet resilience of South Africa. So the index is built using different indicators. So I'm not showing all the indicators here. I'm showing a group. When we group all the indicators into subcategories, this is what you see here. But the idea is, looking at this graph, we can already see where are the weak points. We see that, for example, in South Africa, mobile connectivity is quite good, hitting around 80% here. Market structure is also quite good, hitting around 70% here. But enabling infrastructure, not that good. Mobile networks, not that good. So let's have a look deeper into that. So South Africa, as I mentioned, has a 53% of index, and the weak points are enabling technologies. So we look at what are the indicators, what are the features of the enabling infrastructure, which is a little bit weak. We see data centers, and we see the number of IXPs. Quite a surprise, actually. But so the way the index is built is that it compares South Africa with other countries, those who are performing better. So it doesn't mean that with the number of IXPs that you have in South Africa, it's actually bad. It's just that some other countries are doing better in terms of number of IXPs and number of data centers that you have in their country. So I did a quick calculation. We have seen 20 major cities in South Africa. We have only 7 IXPs and 36 data centers. Normally, in some other countries, you would have a higher number of IXPs because you tend to have regional IXPs. So the ideal scenario will be to have an IXP per city, per major city, where you have a lot of population and also a lot of regional ISPs providing the service. So let me compare this with another country, Thailand, which has more or less the same profile, except that it has a fewer number of cities. It has 8 IXPs and 28 data centers, which means that the number of IXPs as the indicator for internet resilience for Thailand is much better than it is for South Africa, because the ratio is better. So moving on, we've seen a difference in terms of performance as well. So if we compare South Africa to Thailand, in terms of mobile performance is quite equivalent, but if you look at the fixed broadband, the average broadband as experienced by end users, because this is data coming from Ookla, is around 45 Mbps, whereas in Thailand, it's 223 Mbps. If we look at the security and market readiness component of South Africa, IPv6 adoption is very low as compared to other countries in the world. Why is that the case? Guys, what are you doing with the IPv6? I think it's high time for you to make it happen. I was talking about DDoS protection. So what we are measuring effectively here is your potential of harming others. And we get the data from CyberGreen, which is a source of data about DDoS and how many open networks, open DNS servers, open NTP servers that you have on your network. But the good thing about South Africa is that they are doing you are doing quite well in terms of market diversity and upstream provider diversity. So your market is quite well balanced in terms of the number of players and in terms of peering as well. This is the very sad picture of IPv6 adoption. Only 1.5% as seen by Google, as opposed to 42% in Thailand. As I mentioned, South Africa is doing quite well in terms of market readiness, and this is because affordability to internet services is good, peering is good, market diversity is good. So all these different factors are contributing to having a good market readiness factor for South Africa. I will skip quickly. So had some slides on some neighboring countries such as Botswana. So for example, Botswana, we haven't seen any data center recorded on peering DB, which is where we are getting our information. So they are also doing quite badly on fixed on fixed connectivity as opposed to mobile. And I also put a slide on Tanzania. As Frank is here, data center is not that great and fixed connectivity is not that great. So we all have a role to play in this. So if you fix your own network and all aggregated together, this will change your index eventually. So we all have a role to play in making the internet more resilient. So it is not if but when, and I hope it is not you that appear on the blank sheet that's there as the next outage. And if you want to have more information, you can subscribe to our newsletter or have a look at our methodology to have more details about our index. Thank you very much.
Thank you, thank you, Amrish. Very interesting. Hope you can give better numbers next time. Yes. We have time for questions. Yes. Any questions? I think they just realize how much work they have to do now, so everybody's working. Thank you very much. Okay, the next presentation will be a lightning talk about post-quantum crypto, and this is a recording. So please, I don't know who is actually on the recording, but we will now have a recording of a lightning talk.
Hello, I am Atish Chutan, one of the authors of the paper Framework to Test Preparedness Against Quantum Computing. Our research aims to analyze if the TLS servers in Mauritius are correctly implemented to enable quantum-safe cryptography. Since quantum computing is becoming more and more advanced as time passes, we need to increase our internet security to prevent data leaks from cyber attacks. Our framework, which is written in Python, can be found at github.com/atishjutan/tld of failed testing. Our tool is versatile and provides an effective method for other countries or organizations to analyze their own networks for security flaws. What is a TLDO bug? It is a bug where some misconfigured servers or the firewall flags that large TLS client hello packets as a bad connection, meaning the encrypted packets, which is encrypted with quantum-safe cryptography, is classified as a bad connection and rejects it. Even if a connection is made, it will not negotiate for the classical cryptography, then terminates that connection. Our methodology involves fetching a list of IPs corresponding to a country or organization. We then filter them by ensuring that port 443 is open and not blocked by a firewall. To speed up this process, we make use of parallel computing. We finally check for the TLDO bug anomaly in the TLS servers. This rigorous approach allows us to determine the effectiveness of the TLS servers and assess the level of security against the impending threats of quantum computing. I am pleased to announce that our results for the country of Mauritius were found to be 0% failure rate. The 13 IPs in the slides that failed the test are special cases where it connects to the TLS servers but does not return a server hello packet. We also tested for the most popular website in Mauritius with cellular networks. Out of the 47 websites, 3 failed due to being an expired domain. This implies that Mauritius demonstrated a high level of resiliency and preparedness against quantum computing. Thus, the potential of leveraging quantum computing in a cyber attacks against Mauritius is high. This analysis is only the first step to mitigate to post-quantum cryptography. Since we are becoming more and more interconnected, safeguarding our digital infrastructure is a necessity. Our results not only focuses on Mauritius' security, but also points out the vast needs for nations and companies to strengthen their defenses. In conclusion, our work highlights how secure Mauritius is and how serious we are to secure our digital infrastructure. We hope that our framework can serve as a starting point for others to assess and reinforce their digital infrastructure. Thank you.
I see questions. I don't know who's going to answer
I'm
them.
so sorry, this isn't a question, this is a comment. I have no idea who that person was. Do you know who that person was?
I do not know who that person was, but I
Okay.
think the person behind you might know.
Do you know who that person was?
know him personally, but he introduced himself at the talk.
Well, I didn't understand him, and I was trying to understand him, and this is a very important concept and a very important principle. And I think it's been wasted very badly. He spoke about us and what we're doing, and he said things that I think are, besides that it wasn't understandable. I think it's a very relevant topic, and I think it needs to be handled again in a much better way than it was handled here.
Hi.
Look, my son is a postdoctoral student in quantum safe cryptography. He's designing these things. So
Okay.
he's more than happy to come and talk to you and handle questions and answers at a proper academic level.
So, hi, my name is Nishal. I'm part of the program committee. So I can answer a few questions about this, but not everything. Two things. One, the gentleman sent us the slides a little later than his video. So you can find the video and the slides online after the event. I'll say after the event because everybody's busy and they're running around, so you'll get the video and the slides then. If you didn't understand him, it's probably because his native language isn't English, and that's not his fault. But if you care enough to listen to him, you are really, really, really lucky because the talk is recorded. And I'm told, and I'm quite stupid, but I'm told that there's technology today that can help to slow down the speed at which videos play so that people can listen better then. Also note that this is a lightning talk. It was submitted to us as a lightning talk, which meant that he wanted 5 minutes to talk about a topic that he thought was important. And if you didn't get the gist of it is that they wrote some code to test popular websites in Mauritius to see how many of these websites were vulnerable to post-quantum cryptography vulnerabilities, The code's open source, so that's fantastic for first-year university students to have done as a project. They've published it online. You can find it on GitHub, I guess. And the details of where they are, if you couldn't get the URL because of his accent, will be in the slides that will be alongside the presentation. I think they may be online to answer questions. I'm not certain. No, I don't think they're online because they're 2 hours ahead of us. But if you do have questions about their talk, please look online, or you're welcome to come talk to me during the social. Thank you.
Thank you, Nishal. So, for the last part of today, we are having a session about a ZANOG update and a look to the future. It's you.
Thank you very much. Okay. So the thing is that I'm standing in the way of you getting to the beer. So I am going to be very quick and make this a lightning talk. My name is Donald Jolly, and I'm part of the ZANOG team, a volunteer at ZANOG. And I see what everybody means about hitting the button. You've got to hit it hard. So, who's a NOG virgin? Who's never been to a network operator group meeting? You all have. So you all know what a NOG is. There's one person there, fantastic. This is a NOG, right? This is a network operator group meeting. We get together, we share technical ideas, we learn from each other to build a better internet. So what do we do as ZANOG? We organize events like this conference, training, we run mailing lists, Telegram groups. Max mentioned that he started the Discuss group, and he's really keen for somebody to ask him why he started it. So please go ask him. We also have the website running. Then we have the CDN project, and also run community network services and tools. Who knows about the ZANOG CDN project? Okay, so who doesn't know about it? Just checking that everyone's awake. Right, so I'm not going to go into this, but very, very basically, I live in Durban. We're a poor cousin to Joburg. We never get any love there. CDNs don't like to deploy there, although they are slowly coming. So the idea is that we would embed CDN caches into an AS and serve all the local ISPs so that it would save money. And so how does it actually work, the CDN project? Well, it does rely on good people to volunteer their time, sponsorship of Cashful, rack space, power, and we also got donations to get the money for an AS because, Afrinic and their fees. And we then approached CDNs, and we still are adding to that slowly. But really, what's important about this is you have to set up bilateral sessions with ZANOG in order to get that content. So as I said, the community services that we offer are the CDNs. We have a Microtech B test server running so that those people that are connected to the exchange point can use that. Microsoft connected caches. I'll punt this one and say I've got a great story about the Microsoft connected cache. Come ask me about it. And then NTP servers. So what's new? So that's what this is about, right? We deployed in PE and connected to NIMBINX, Nelson Mandela Bay Internet Exchange Point. We took one of the OCAs from Durban and we put that into service there, and a Microsoft connected cache. Very recently, Ed has been working hard and getting additional hardware, and so we are planning on spinning up services, and I'll get a little bit into that in the next couple of slides. So then we got a new CDN in Cape Town in the Durban cluster, the Steam cache, which has been performing very well. So I think I actually have to, thanks to sponsors, you see them here, for making events possible. Also in the background, there's a continual sponsorship of Rackspace, Power, Cashful, and thanks to the volunteers that spend a lot of time. Ed, you spend so much time on this. So yeah, thanks very much. And then we've just put up a link for donations for Cashful, hardware, and those sorts of things. So what's next? When I was doing these slides, the server was on its way to Durban. It arrived super quick and was put in and is in production. As I mentioned, we're getting additional servers and compute. And the idea of that is so that we can offer more services to the community. But the important thing here is that we spin up services that the community find useful. It's pointless us saying, well, let's host a Wikipedia what do you call it, node or whatever the case is, when, well, actually, no, we don't really need that. So ideas are iPerf server, Jitsi video bridge, Mastodon server, but it's actually up to you. And then we're going to carry on with our regional events. We had one last month in Gauteng, and we'll have one next month in Durban. And I think the idea is that we also would like to do some training before those regional events. Those regional events are usually just evening talks and drinks. So everything moving forward actually depends on the community. So I know that we all want to get out of here, but we need input from you. And one of the things that at the last GPNOG, Nichelle stood up and he said, we need ideas for training. Who needs training? And there wasn't a huge amount of feedback on it. So what I want to ask now is some ideas on how we move forward with this community and things that you would like to see happen. So do you think we should be not worrying about training, or if we do, what topics? Should we be having more events, less events? What services? If we can just maybe have 5 minutes chatting about it, and then we can continue to chat about it over milk and cookies.
You guys are amazing. Don, Ed, Nichelle. I mean, those are the only ones that I know. I know it's a thankless job. I know you don't get paid for it, and I thank you from the bottom of my heart. You've really taken over a lot of the space where ISOC ZA was pretty much trying to fill, and we lost momentum, and you guys came in with full speed momentum. And you've made a huge difference to our community. There's no doubt about it. You've created a community, you've created interest, you drive interest. So thank you so much. You're doing great. Don't worry too much about this thing. It's amazing. So I think we need basic training, like basic networking, the prerequisites for any networking course. Why to route a /29 rather than 2/30s? You know, they don't teach that in the basic training of Micritic or Cisco or Juniper. I know that we used to have some basic training by Afrinic. Mukum used to come. Nichelle knows how to do it. He's done it many times before. I've been in those IP training sessions, the basic ones, which include like some basic Unix as well, because we've got people that don't know Unix. So you're getting onto the command line. And I've got people that we can send, and I'll fill up those trainings, and I'm prepared to volunteer to help you guys out on that as well. I believe it's very important. we've put DNS training back onto the map, and that seems to be happening annually, and I'm assisting to make sure that happens annually in Cape Town. Mark Elkins and Johan Iren do that. So I'm hoping for number training as well. We've got names going. Okay, basic number,
Okay.
how to use the numbers. And that'll also have some basics on IPv6, obviously, as well. Question, I know it's a secret, and we're not allowed to talk about it. The Google CDN. Does anybody, I mean...
For Cape Town.
Yeah, Cape Town.
Yeah, so there's two challenges with that. I think the first one is the cache flow requirements for a Google cache are quite high. When you look at the likes of Apple and Steam, their ratios are fairly good, but Google is not. It's still relatively good. You know, it's I think 1 to 3. So that it is quite bandwidth intensive. So we would need to figure out how to make that sustainable in terms of the cache flow. And then the other one is actually getting a buy-in from Google, because they seem to be falling off the map in terms of actually being helpful.
Hello, this is Arden from ZANOG Group. I think automation training, like those previously delivered, would be more tailored for, especially myself. And VM, like virtual machine, working, how you can integrate that with networking, would be a nice training topic, I think.
Okay, yeah, thanks very much. So yeah, but you know about that training. I hope you've registered for it for. Yeah. Thursday. Yeah. All right. So I think, please come chat to Ed or myself about ideas that you have, services that you feel that we should be spinning up, and we would like to have some tech volunteers to help us manage that as well. Yes, Nichelle.
Hi, my name is Nichelle. I have a ZANOG hat too, as one of the background people that has to write all the documentation for funding, it seems. I want to comment on something that Alan said. He's right. I've been to his facility, his training center in Cape Town. He was very kind to host us many times over the years. We've done training there. I do actually know how to subnet, even in my head, and I'm pretty certain I can teach most people how to do that. The thing is, I don't want to do it anymore. Because I'm going to be 25 next year. And that's like a quarter of a century, right? I'm old. So there needs to be other folks that want to come do it. I'm looking at this room, and maybe it's just the old-timers that didn't have the energy to get up and leave that's here. But there are no kids here, right? There's one child, that's here. But where are the rest of us? I mean, what are we doing to bring younger folks in and to teach the younger folks the things that they need to be doing so that we can get them involved in here? So I don't ever want to teach. I met most of you because I used to teach IPv6 a long time ago. I don't ever want to teach an IPv6 course again in my life. That's how sick I am of teaching IPv6. But I'm very happy to spend time to teach younger folk who are willing to teach IPv6 to the, Alan's grandchildren or whoever's going to come next. But that's what we need here. So for those of you that are business owners, for those of you that are, you own your business, you see levels or whatever in your business, where's the young guys? Why are they not at these events? Is there some secret code where you think that iWeek or ZANOG is only if you hit like engineer level 3? Is that a thing?
They became programmers. It's more sexy.
Is it that they're all just busy writing apps and they want to push something to go yo and make $1 million or something? Right? Because, and if that's real, then if that's real, then part of what we need to be doing is rethinking how we're bringing people into the industry. And let me remind you about this. You're all invested in whatever, I'm sorry, I'm not intentionally showing you my backside. But you're all heavily invested in whatever you decide to do here. Because the young people that are going to get trained are people that you're going to look for your employment force. So when Donald says, what do you want a future NOG to be? It's not just, hey guys, next year what version of whiskey do you want? It's, how do you see yourself getting talent? Because you're up against, like the keynote said this morning, for those of you that were awake, the keynote said you're up against the fangs of the world who are stealing all of the folk that you have. What's your plan to replenish these skills? You don't have a plan? Well, yeah, I know you're Cape Town, Slapstad. That means sleepy town for the non-Afrikaans people, I think. But what's your plan to get new folk? Is it secret? You don't want to tell us? If it's secret, that's fine. I'll go back to my seat. But I don't need to work at an ISP anymore. I've paid my penance. I've done that already. How are you going to get new kids in?
Sean?
Make me walk so far so late in the day. Sure. Sean from the internet for this conversation. I chaired a panel in November at ZAPF on this exact topic. And I've thought about it a lot since then. I've also got 2 teenagers going into the workforce and trying to figure out what they want to do with their life. My oldest one has decided developing and writing code is far more fun than network engineering. I think part of the problem for any younger people coming to an event like this is the demographic is just older. The way to solve that is, unfortunately, just get more young people here. So as Michelle says, if we have younger people who work in organizations, they need to be encouraged to attend events like this. But I think in addition to events like this, having a different platform for a newer generation where training and information and data, and as Alan says, like how to configure routers, how to choose subnets, basic things. I mean, people who not even just want to come in and work for an ISP, but anybody trying to start an ISP who may have network experience from being in tech support or whatever, there's a lot of nuances in running an ISP, like we found out when we started 10, 12 years ago, that just isn't available. Like this information isn't there unless you can get to a training day, which not everybody can. And I think building something where that training data lives, where people can work through that information, will be massively helpful in allowing youngsters to access it, and by the time they attend an event like this, they know what a /30 is. So a lot of people rock up here and go like, I don't even know what that is. I want to be a network engineer. But a lot of the talks too are very, very technical. So I think it's beneficial to, I know for those of us who've been around the block for a couple of years, a very basic, straightforward 101 talk might be very boring, but maybe that's in a breakaway room somewhere like networking 101, peering 101 or whatever. But anybody who's new to the industry, anybody who's worked in the industry less than 12 months or 36 months should be attending those kind of talks, which are often missing at events like this.
Thanks, Sean. I think we're going to close it off there because Ed's getting thirsty. Oh, Ed wants to say something. It's fine. It's on you now.
Hi, I'm Ed De Lange. I'm Chief Bottle Washer for NOG. So just the one thing that Donald didn't quite touch much on, but we get sponsors for lots of things for ZANOG. This event is a good example because that board is full of great people who chuck money at us to do things like this. Because people forget actually how expensive it is to run these events. Because, well, food's expensive, beer's expensive, everything goes on. But a lot of the other things we do, we get support from people to do the smaller projects and sort of running thing. So I was asked, well, on the NOG mailing list or Telegram group a couple of weeks ago, I asked if anyone had spare 2.5-inch drives for some of our servers. A whole bunch of people came and said like, sure, here's 2.5-inch drives. We've got some sitting on the shelf. Someone ordered some in and just said, where can I courier it to? It came straight from the warehouse to us. It's great for support like that. But people also asked, can other people support us in smaller ways? Because not everyone has drives floating around, or in some cases 100,000 Rand to chuck at an event. So that's why we did that sponsors link that Donald had earlier on. So if someone wants to give $100 to supporting this, they can go and do $100 monthly or whatever. So it helps us a lot to deal with some of the smaller stuff rather than having to, okay, we want to buy a drive, now let's find someone to buy us a drive. It just greases the wheels a bit easier, and that doesn't go to anyone's pocket, that always goes into something community. So yeah, if anyone wants to consider that, the link is on the website, and every bit really helps. And if your company wants to sponsor some events, our regional events cost us about 20,000 Rand to host per event, so if anyone wants to sponsor one of those or part of those, please reach out to us as well. Thank you very much.
All right, so I think that is the end of day one, and cocktails in the courtyard. Thank you very much.